We've learned that one of the ways that you can measure the concentration of a solution, obviously we talked about, is you can taste it and say, oh, it's too sweet, or it's not sweet enough, or it doesn't have enough flavor. Mathematically, you can also do it by doing what's called the percent by mass, by taking the mass of the solute and dividing by the mass of the solution and then multiplying by 100 to get a percent. And both of those are perfectly fine ways of either mathematically or non-mathematically talking about the concentration of a solution. But the main way that we measure the concentration of a solution in chemistry is by using something that's called the molarity. Okay, and the molarity, we abbreviate molarity first of all with a capital M. So for example, when I go into our stock room and I get some chemicals that are dissolved in water off of the shelf, I want to know how concentrated they are. And so many times I'll go in and it'll say 2.5 big M HCl. And that means that that solution of hydrochloric acid has a concentration of 2.5, and that the units that we use is what's called molarity. So the molarity of the solution is 2.5. Or it might be 0.125. Or it might be 12 M. Okay, and I'll tell you right now, that number is getting really, really high. Like if we have 12 molar HCl, that's like we do it in a fume hood. When we take the lid off, we have gloves on and we don't breathe the fumes. That's really, really concentrated hydrochloric acid. Whereas down here, the 0.125, not as concentrated. However, you don't want any of that ever on your skin. So, but it's just useful in terms of what's a safe a safe concentration to use with students is we typically measure that in what's called molarity. Now, how do you calculate the molarity of a solution? Is typically when you measure something out, you measure the mass of something in grams. Okay, but we've also learned that you can convert those grams to moles. So the top part of the molarity equation is the moles of the solute. Remember, the solute is the stuff that you put into the water. Okay, and then the bottom part of the solution is the volume or the liters of the solution. And remember, the solution includes the water and the solute, the stuff that you're adding into it. So, for example, let's look at this first one here. What is the molarity of a solution that contains 2.56 moles of HCl in 2.5 liters of solution? So, and typically with molarity, it pretty much always is going to come as solution. Remember with percent by mass, I said, sometimes it's water, but sometimes it'll say solution, so you got to be careful. With molarity, it really doesn't. Usually when you get the volume of a solution, it's going to be the volume of the water and the HCl or the salt or whatever you're putting in there together. So notice here I take my 2.56 moles, I put it on top, I put 2.50 liters on the bottom. That should be a capital L there, sorry. Okay, and then we divide those numbers and then we get 1.02. And again, you can write that as 1.02 moles over liters, because that's really what it is. It's moles over liters. Or you can just abbreviate molarity by just writing a capital M. So 1.2 moles over liters or 1.02 capital M. Okay, let's look at a second example here. This one says, calculate the molarity of a solution created by dissolving 225 grams of sugar, and they give you the chemical formula, in 250 milliliters of solution. This is a very, very common answer, very common type question, where instead of giving you the moles of something, they give you the mass. And then the first thing you have to do is you have to use the molar mass of sugar, which you got to figure out that, and convert that to moles. So you can see that's the first thing that I did here, is I took my 225 grams, and then I had to go to the periodic table and figure out the mass of C12H22O11, and it's 342. So I took 225, I divided by 342, and I converted to moles of, again, this sugar or sucrose. So I have 0.658 moles of sucrose. Now, so the amount of sugars in grams, we converted that to moles. But also notice, and this is really the only other way that this happens, is that the volume of the solution I gave you was in milliliters. As soon as you see the volume in milliliters, you've got to think, no, it needs to be, remember up here, liters. Remember the equation? Liters. It has to be in liters. So it's really, really easy, but if you forget to do it, you're going to mess it all up. Okay, you have to convert the milliliters to liters, and how do you do it? Move the decimal point 3 spaces to the left. So anytime you have a solution that's the volume is given in milliliters, you're going to take that decimal point, so 250, and has the decimal point here, you're going to go 1, 2, 3, and that equals 0.25 liters. What if it was 50 milliliters? Then same thing, 1, 2, 3. See that empty space we have right here though? That would be 0.050 liters. If it's 125 milliliters, that equals 0.125 liters. Okay, so every time I'm moving the decimal point, what if it's even just something like 10 milliliters? 10 milliliters equals 0.010 liters. Notice every time I start at the end of the number and then I move that decimal point 3 spaces to the left. Okay, so in this case, what did we do? We got the moles by converting the grams to moles, and then I converted my 250 milliliters to 0.250 liters, and then I simply go to my calculator. 0.658 divided by 0.250 gives me the concentration in molarity. Okay, let's look at one more example here, and then we'll do a few together. So, example 3, how many moles of a substance are dissolved in 3.25 liters of a solution with a molarity of 0.258? This one's a little bit different. So remember, the equation is molarity equals moles over liters. In this problem, they're giving you the liters and they're giving you the molarity, and they're asking you to find the moles. So same situation, but now we're just solving for something different. How do we get moles by itself using algebra? Is we have to multiply both sides by the liters. Okay, and so to do that, we're going to simply move the liters over here, and liters times the molarity is going to equal the moles. So here you can see that you must multiply the molarity and the volume to find the moles. So molarity here, volume here, the liters are going to cancel. We take 0.258 and we multiply by 3.25. So we took the molarity from here, we took the volume from here, we multiplied them together to get moles. All right, let's, so at this point, that's a good introduction there. At this point, you can go ahead and pause the video and try to do as many, I think there's 4 of them. Try to do as many of these 4 examples as you can by yourself. Once you're done with those, then go ahead and come back to the next video, and I'm going to do these 4 examples for you in the next video.